I often catch myself lost in these quiet evenings, gazing up at the starry canopy, feeling the weight of questions that have haunted thinkers for millennia. What drives us to seek the first breath of the universe? That elusive moment when everything that exists emerged from what? From nothing? From something eternally present? From a predecessor we can barely imagine? The question itself feels almost too large to hold in one mind. Yet here I am turning it over like a smooth stone worn by countless hands before mine. When I think about the end of the dark era of the universe, that incomprehensibly distant future when the last stars have flickered out and black holes themselves begin to evaporate, I find myself paradoxically drawn back to beginnings. Perhaps this is natural. Endings and beginnings feel like two faces of the same coin, don't they? The ancient Greeks understood this with their Ouroboros, the serpent eating its own tail, suggesting that conclusions contain within them the seeds of new starts. But I wonder if we've been asking the question in quite the right way. The standard story, the one I learned and the one most of us carry in our minds, speaks of a singularity, a point of infinite density where all the laws we know break down. It's a boundary in our equations, a place where the mathematics simply stops working, like a map that ends at the edge of known territory with the ancient warning, "Here be dragons." I remember the first time I truly grasped what this meant. Not just that we didn't know what happened before, but that the very concept of before might dissolve at that boundary. Time itself, woven into the fabric of space-time, might not extend beyond that point. It was dizzying, this idea that the question, what came before the Big Bang, might be as meaningless as asking, what lies north of the North Pole? But reflecting more deeply, I've come to see that this singularity is perhaps less an answer and more an invitation. It's our current understanding holding up its hands and saying, "This is as far as I can take you." And isn't that precisely where the most interesting thinking begins? When I look at a cliff face in the mountains, I don't assume the world ends there. I assume there's something beyond I haven't yet seen. Why should the mathematical singularity be any different? This is where my thoughts turn to what physicists call the bounce. I find this metaphor deeply satisfying. The image of the universe not emerging from nothing, but rebounding from a previous contraction, like a cosmic spring compressed to its limit and then releasing. Loop quantum gravity, with its granular view of space-time itself, suggests that at the smallest scales, space isn't smooth but woven from discrete threads. When the universe contracts in this picture, it doesn't collapse to a point of infinite density. Instead, quantum effects create a kind of resistance, a pressure that eventually reverses the collapse and sends everything expanding outward again. I think about this often when I'm walking through a forest after rain, watching droplets fall from leaves and bounce off puddles. The water doesn't disappear into the surface. It rebounds, creating ripples that spread outward. Could our universe be one such ripple spreading from a bounce so profound it reset everything we think of as initial conditions? And if so, what was the universe that came before? Was it like ours, governed by the same laws, or something utterly alien? These questions pull me forward, even though I know the answers may forever dance just beyond our reach. The beauty of the bounce scenario is that it preserves causality in a way the classical singularity does not. There's a history, a story that extends backward through the bounce into a contracting phase, but it also raises profound questions about cycles. If the universe can bounce once, why not infinitely many times. Am I sitting here typing these thoughts in just one iteration of an eternal cycle? The philosopher Nietzsche spoke of eternal recurrence, the idea that everything that has happened will happen again, infinitely. He meant it as a thought experiment about how we should live if every moment would repeat forever. But what if he was accidentally prophetic about the cosmos itself? Yet I pause here, because something troubles me about infinite cycles. Each bounce, each contraction and expansion seems like it should leave some mark, some inheritance passed from one universe to the next. Information might flow across the bounce, perhaps encoded in the quantum geometry of space itself, or in the patterns of fields that survive the transition. This makes me wonder, are we carrying forward echoes of previous universes? Are the fundamental constants we measure, the ones that seem arbitrary, the strength of gravity, the mass of the electron, actually memories of countless previous bounces, gradually refined through cosmic selection? This thought connects to something I find both beautiful and unsettling: the anthropic principle, the observation that the universe seems remarkably fine-tuned for the existence of conscious observers like us. Change any of several fundamental constants by even a small amount and stars wouldn't form. Chemistry would be impossible, and we wouldn't be here to wonder about it. Some see this as evidence of design, others as a selection effect. We necessarily find ourselves in a universe capable of producing us, just as fish necessarily find themselves in water. But in a cyclic cosmology, perhaps each bounce slightly varies the constants, and we exist in one of the rare iterations where everything aligned just right. Does that make our existence more or less meaningful? I'm not sure I know. Contemplating deeper still, I find myself drawn to an entirely different class of ideas, ones that expand the picture not in time but in dimensionality. String theory and its descendants speak of extrae, dimensions beyond the three of space and one of time that we experience. In some versions, our entire universe, everything we can see and everything we can't, might be a three-dimensional brain, short for membrane, floating in a higher dimensional space called the bulk. It's like being a character drawn on a piece of paper, unaware that the paper itself exists in a three-dimensional room. In this picture, the Big Bang might have been the collision of our brain with another. Imagine two vast sheets drifting through higher dimensional space, occasionally bumping into each other. Each collision releases enormous energy into both brains, energy that we would experience as the hot, dense beginning of our universe. The end of the dark era then wouldn't be an absolute end, but perhaps a gradual drift toward another collision, another cosmic reset. Time becomes not a line with a beginning and end, but part of a larger pattern we can only glimpse from our limited perspective. I try to visualize this sometimes, though I know my three-dimensional brain isn't built for it. I think of soap bubbles floating in air, occasionally touching and merging. But that analogy fails because the bubbles in the air are all in our three-dimensional space. The reality that these theories describe involves dimensions we literally cannot point to or even properly imagine. It's humbling, this limitation. We pride ourselves on understanding, on building theories and models, but we're fundamentally constrained by the architecture of our minds and senses. What strikes me most about the brain collision scenario is how it reframes our cosmic isolation. If our universe is just one brain among potentially many, then the bulk might contain countless other universes, each with its own history, its own laws, perhaps even its own forms of complexity and consciousness. We would be part of a vast multiverse, but one structured very differently from the quantum many worlds interpretation or the eternal inflation picture. Here, other universes aren't branching probabilities or distant bubble regions of space time. They're literally other sheets of reality, separated from us by dimensions we can't access. This makes me wonder about uniqueness and meaning. If there are countless other universes out there in the bulk, does our particular universe matter less? Or does it matter more precisely because it's ours, the one we inhabit and can influence? I lean toward the latter view. A parent doesn't love their child less upon learning that billions of other children exist in the world. Specificity creates meaning, not universality. As I write this, I'm aware of how far we've traveled from the initial question about why the dark era ends. Or have we? Perhaps understanding possible beginnings helps us understand possible endings and transformations. If the universe emerged from a bounce, it might contract again toward another. If it emerged from a brain collision, perhaps another collision awaits in the incomprehensibly distant future. These aren't separate questions, but woven together in the very fabric of cosmological thinking. There's something almost poetic about how physics, when pushed to its limits, starts to sound like philosophy or even mysticism, not because it becomes less rigorous, but because it confronts the same fundamental mysteries that have always captivated human thought. What is the nature of existence? Where do we come from? Where are we going? Physics offers tools, mathematics, observation, experimentation, but at the edges, we're still standing in that same space of wonder and uncertainty that our ancestors inhabited when they looked up at the night sky and asked, why? I think that's why I keep returning to these questions, even though I know I may never find definitive answers. There's something in the asking itself that feels essential, that connects me to a chain of questioning stretching back through every generation that has ever contemplated the cosmos. We're all part of this great conversation about existence, adding our voices to a chorus that began when the first conscious beings looked outward and wondered. And that, perhaps, is answer enough for now. Continuing from where we left off, I find myself drawn deeper into what might seem like emptiness, but is anything but. When we speak of the dark era, that almost unimaginable future when even black holes have evaporated and the universe has cooled to near absolute zero, we might picture perfect stillness, a cosmic silence so complete that nothing could ever disturb it. But I think this intuition misleads us because even the vacuum itself, even what we call empty space, is far stranger and more active than our everyday experience suggests. The quantum vacuum you see isn't truly empty. It's more like a boiling sea, constantly churning with fluctuations, pairs of particles and antiparticles briefly blinking into existence and then annihilating each other, energy borrowed from the universe for the tiniest fractions of a second before being repaid. These aren't merely mathematical abstractions, they have real, measurable effects. They push on metal plates placed close together in the void. They shift the energy levels of atoms. They're woven into the very fabric of reality as we understand it. When I contemplate this seething vacuum, especially in the context of the dark era, I'm struck by a profound question. Could these fluctuations themselves be seeds of transformation? If the vacuum can spontaneously produce particles even in our current universe, what might it do over the incomprehensibly vast timescales of the dark era? We're not talking about millions or billions of years here. We're talking about time periods so long they make the entire history from the Big Bang until now seem like less than an eye blink. In such expanses of time, even the most improbable events become not just possible, but perhaps inevitable. This brings me to one of the most vertigo-inducing ideas in modern cosmology: eternal inflation and the multiverse of bubble universes it implies. The basic picture goes like this: inflation, that brief period of exponential expansion in the early universe that smoothed out irregularities and set the stage for everything that followed, might not be a one-time event. In many models, perhaps most models, once inflation starts in one region of space, it creates conditions where other regions continue inflating, even while some regions, like the one that became our observable universe, stop and transition into the slower expansion we observe today. Imagine a pot of boiling water with bubbles forming constantly. Each bubble is a universe like ours, emerging from the inflating water and expanding. But the water itself keeps inflating and producing more bubbles forever. Our entire universe, everything we can see, everything we ever could see, even with perfect instruments, is just one such bubble. And the eternally inflating space outside our bubble continues to spawn countless others, each potentially with different initial conditions, perhaps even different fundamental parameters. I find myself pausing here, trying to hold this picture in my mind. It's dizzying. If eternal inflation is real, then the multiverse isn't just large. It's infinite, not infinite in some abstract mathematical sense, but infinite in the most literal way. An endless sea of bubble universes, more being created in every moment, stretching on forever without boundary or limit. The dark era that awaits our universe is just our bubble's fate. Other bubbles might have already reached their own dark eras. Still others might be young, filled with newborn stars. And the inflation field outside all the bubbles just keeps inflating, keeps creating eternally. But reflecting more carefully, I notice something curious about this picture. The bubbles themselves, the individual universes, don't last forever in their current state. Our bubble will expand, cool, enter its dark era, and eventually reach a state of maximum entropy where nothing interesting can happen anymore. So we have this strange combination, an eternally creative process, the inflating field, giving birth to individual universes that each have finite lifetimes of complexity and structure. Creation without end, but each creation is mortal. Does this make our existence more meaningful or less? I lean toward more, though I understand why others might feel differently. Yes, we're one bubble among infinite bubbles, which might seem to diminish our significance, but each bubble is genuinely unique. Its quantum fluctuations during inflation create a one-of-a-kind arrangement that has never existed before and will never exist again in quite the same way. We're not interchangeable copies. We're singular, irreplaceable, even in an infinite multiverse. There's also something profound in the thought that the creative process never ends. Our universe will fade, yes, but the larger structure, the eternally inflating field, continues its work. It's reminiscent of biological evolution. Individual organisms die, but life itself persists and continues to explore new possibilities. Individual universes die, but the multiverse continues to generate new worlds, new possibilities, new experiments in cosmic creativity. We're part of something that transcends our individual fate, something genuinely eternal. Yet I must be honest about what troubles me in this picture. The bubbles once formed are causally disconnected from each other. The space between them expands so fast that nothing, not matter, not light, not information, can travel from one bubble to another. We're isolated, sealed off forever from all those other universes. In principle, we can theorize about them, but we can never observe them directly. never communicate with whatever forms of complexity or consciousness might arise in them, never even confirm that they exist. This isolation raises a philosophical question that I find myself returning to repeatedly. Does something exist if it can never, even in principle, interact with us? Our entire universe could be the only bubble that ever inflated, or one among infinite bubbles, and there's no observation we could ever make that would tell us which is true. The multiverse becomes, in a strange way, a matter of metaphysics rather than physics. We choose to believe in it or not based on our interpretation of our best theories, but we can't test it empirically. Some might say this means we should reject the multiverse as unscientific, but I think that's too hasty. The theories that predict eternal inflation, theories of quantum fields and gravity, are tested and confirmed by many observations within our own universe. The multiverse isn't an additional hypothesis we add on. It's a consequence that falls out of theories we have independent reason to believe. It's like accepting the far side of the moon exists even when we can only see the near side. The same physics that explains what we observe implies there's more we can't observe. Contemplating these bubble universes, I'm also drawn to questions about variation. Do the bubbles differ only in their initial conditions, how matter and energy are distributed? Or do they differ in their fundamental laws and constants? This matters enormously. If the bubbles all follow the same physics, then the multiverse doesn't address questions about fine-tuning. We'd still have to explain why the laws are what they are, why the constants have the values they have, why this set of rules rather than some other. But some versions of string theory suggest that different bubbles might settle into different vacuum states, different solutions to the equations, each corresponding to different values for what we think of as fundamental constants. In this picture, some bubbles might have stronger gravity, different particle masses, different forces. Most would be sterile, unable to form stars or planets or any complex structures. But in an infinite multiverse, even very rare combinations would occur, and we necessarily find ourselves in one of the rare bubbles capable of supporting complexity and consciousness. This is the anthropic principle applied to the multiverse. We observe a life-friendly universe not because the universe was designed for us or because these are the only possible laws, but because we could only exist in one of the rare bubbles where the conditions allow it. It's a selection effect. We're observational survivors existing in one of the possible universes where observers can exist. I find this both elegant and somewhat unsatisfying. Elegant because it potentially explains fine-tuning without invoking design or necessitating that our universe be the only possible one. Unsatisfying because it means many questions we might ask. Why is the electron mass what it is? Or why does gravity have this strength? Have the answer, no reason, it's different elsewhere, but we're here because here has the values that work. It trades deep explanations for probabilistic selection. Yet perhaps that's the nature of ultimate questions. Perhaps when we push far enough back in the causal chain, we always reach a point where the answer is something like, that's just how it is, or all possibilities are realized somewhere. There may be no deeper why, just the brute fact of existence exploring all its options. This doesn't satisfy our hunger for ultimate explanations, but maybe that hunger is asking for something reality doesn't provide. Returning to the dark era and its ending, the eternal inflation picture offers a curious perspective. Our bubble universe will indeed enter its dark era, cool toward absolute zero, reach maximum entropy. But in the larger structure, the inflating field continues. Bubbles continue to form. The cosmic creativity continues unabated. The end of the dark era in our bubble is just one local event in an eternally productive multiverse. There's no cosmic ending, only local transformations. But wait, is that true? Even the eternally inflating field exists in time, unfolds according to physical laws, borrows its energy from somewhere. Can inflation truly be eternal in the past direction as well as the future? Here we encounter deep puzzles. Some theorists argue that eternal inflation must have had a beginning, that the inflating field couldn't have been inflating forever backward in time. Others propose that it could be eternal in both directions, or that it emerges from some more fundamental structure that itself is eternal. These questions take me back to where I started, to the beginning of part 1, questioning what beginning even means. Does eternal inflation solve the cosmological origin problem, or just push it back a step? If the inflating field is eternal, we've replaced the question, what caused the Big Bang, with what maintains eternal inflation? We've traded one mystery for another, perhaps a more manageable one, but a mystery nonetheless. I think this is actually progress, though. Each iteration of cosmological theory doesn't necessarily give us final answers, but it often gives us better questions, more precise formulations of what we don't understand. We've moved from, why is there something rather than nothing, which might not even be a well-formed question, to what determines the properties of the inflating field, and how do bubble universes nucleate? These are still enormously difficult questions, but they're ones we can approach with mathematical models, ones that make predictions, even if those predictions are about inaccessible regions, ones we can refine and test against observations. The picture of the seething vacuum spawning bubble universes eternally captures something I find beautiful about modern physics. It reveals that apparent emptiness is full, that apparent endings are transitions, that what seems local and unique might be part of an infinite pattern. The dark era looks like death from inside our bubble, but from the perspective of the multiverse, it's just one phase in one bubble among infinite bubbles, while the larger process continues its eternal dance of creation. Proceeding further into these contemplations, I find myself confronting what might be the most fundamental asymmetry in nature, the arrow of time itself. Why does time flow in one direction? Why do we remember the past but not the future? Why do eggs break but never spontaneously reassemble? The answer, as best we understand it, lies in entropy, that measure of disorder, or, more precisely, the number of ways a system can be arranged while still looking essentially the same. The second law of thermodynamics tells us that entropy always increases in closed systems. It's not that individual particles know they should move toward disorder. It's that there are vastly more disordered states than ordered ones. So random processes naturally explore that larger space of possibilities. When I shuffle a deck of cards, I'm extraordinarily unlikely to produce perfect sequential order by chance, not because disorder is preferred, but because there's only one perfectly ordered arrangement and billions of disordered ones. But here's what fascinates me. The second law, and therefore the arrow of time, only makes sense if the universe started in an extremely low entropy state. The Big Bang wasn't just hot and dense, it was highly ordered, with energy distributed remarkably uniformly. This seems counterintuitive. Shouldn't a hot, dense state be high entropy? But no. For a gravitating system like our universe, having matter spread smoothly is low entropy. High entropy would be everything collapsed into black holes, the most disordered gravitational state possible. So the arrow of time, the reason we experience a direction to temporal flow, traces back to the initial conditions of the universe. We experience time flowing forward toward higher entropy because we exist in a universe that began in an improbable low entropy state and is still evolving toward equilibrium. The question, why does time flow forward, becomes, why did the universe begin with such low entropy? And I find myself back at the beginning again, questioning origins. The dark era in this framework represents the universe approaching maximum entropy, what's sometimes called heat death. All the stars have burned out, all the black holes have evaporated, all the matter has decayed or dispersed, and what's left is a thin soup of radiation and particles at nearly uniform temperature, spread across an ever-expanding space. At this point, no further work can be extracted from the system. There are no temperature differences to drive engines, no gradients of any kind to power processes. It's not that everything is cold, though it would be extraordinarily cold. It's that everything is the same. In such a state, does time still flow? Physically, yes, particles still move, fields still fluctuate. But experientially, arguably, the arrow of time would disappear. Without entropy gradients, without change that goes somewhere rather than merely fluctuating randomly, would there be any meaningful sense of before and after? This is the universe in equilibrium, and equilibrium is, in a sense, timeless. Yet I wonder whether this heat death is truly the end. The universe is expanding, driven by dark energy. This expansion creates new volume, new space into which entropy can spread. In a strange way, the expansion provides a kind of escape valve. The universe can keep increasing its total entropy indefinitely by simply growing larger. The entropy per unit volume might approach a maximum, but the total entropy keeps rising because the total volume keeps rising. Does this change the picture fundamentally? I'm not entirely sure. There's also the question of whether maximum entropy truly means nothing can ever happen again. Even at equilibrium, quantum fluctuations persist. Over absurdly long timescales, far longer than anything we can meaningfully imagine, these fluctuations might occasionally produce ordered structures purely by chance. It's like the shuffled deck of cards. Given enough shuffles, you'll eventually get sequential order, not because there's any force making it happen, but purely by random exploration of all possible arrangements. Some cosmologists have speculated about Boltzmann branes. The idea that in an eternal equilibrium universe, random fluctuations would eventually produce conscious observers. But these observers would be much more likely to be briefly existing, isolated brains with false memories than entire civilizations with consistent histories. It's a deeply strange idea, one that troubles our understanding of probability and existence. Are we such fluctuations? Almost certainly not, given the ordered cosmos we observe around us. But the fact that we can even ask the question reveals how strange the implications of eternal time at maximum entropy become. This brings me to another radical possibility that has gained attention in recent years: the simulation hypothesis. The idea is simple to state. What if our entire universe, including all of us and our experiences, is a computer simulation running in some higher level reality? Perhaps advanced civilizations routinely create such simulations, and if so, simulated universes might vastly outnumber base reality universes, making it statistically likely that we're in a simulation. I confess this idea simultaneously intrigues and troubles me. It's intriguing because it offers a kind of answer to the fine-tuning problem. Our universe's laws are what they are. because they were programmed that way by the simulation's designers. It also provides a framework for thinking about why mathematics describes physics so well. If the universe is computational at its base, mathematical structure is exactly what we'd expect to find. But recent work has cast serious doubt on the physical plausibility of the simulation hypothesis, at least for simulations running in universes with physics like ours. The amount of energy required to simulate even a small portion of our universe at full resolution, tracking all the quantum states, all the particles, all the fields, is astronomically large, far exceeding the total energy available in the observable universe. To simulate the entire universe would require computational resources from a universe with fundamentally different physical laws, particularly regarding the relationship between information and energy. Does this definitively rule out the simulation hypothesis? Not quite. The simulation might be lower resolution, only computing details when observers look closely, the way video games render only what's visible to the player. Or the simulating universe might indeed have very different physics that make such simulations easier. Or our universe might be a self-simulation, somehow simulating itself through physical processes. A conceptually difficult idea that I struggle to wrap my mind around. What strikes me most about the simulation hypothesis is how it reframes old philosophical questions in modern language. Plato's allegory of the cave suggested we might be seeing only shadows of true reality. Descartes wondered if an evil demon might be deceiving us about the external world. The simulation hypothesis is essentially the same question. Is the reality we experience the base level of existence, or is there something more fundamental beneath or beyond it? I lean toward thinking we're not in a simulation, based on the energy constraints and the absence of any positive evidence for it. But I acknowledge this is partly an aesthetic choice. The simulation hypothesis feels unsatisfying to me because it doesn't actually answer the deepest questions, it just relocates them. If we're in a simulation, what's the nature of the reality running the simulation? And if that's also a simulation, what's the base level? We end up with either an infinite regress or a base reality. And if we need a base reality somewhere, why not assume ours is it? Yet the very fact that we can seriously entertain such ideas speaks to how far our cosmological thinking has come. We're no longer asking merely, what are the stars? But what is the nature of reality itself? Are there levels of existence beyond what we directly observe? Could our universe be information processing all the way down? These are profound questions that blur the boundaries between physics, metaphysics, and philosophy. Returning to entropy and the dark era, I'm struck by how the arrow of time connects to questions of meaning and purpose. We exist because we're far from equilibrium, because there are gradients to exploit, because there's useful energy available to build and maintain complex structures like our bodies and brains. As the universe ages and approaches equilibrium, such structures become harder and harder to maintain, eventually impossible. The heat death isn't dramatic. No explosion or cataclysm, but a slow fading, a gradual loss of the capacity for anything interesting to happen. This fills me with a peculiar melancholy. The universe that gave rise to stars and planets and life and consciousness will eventually reach a state where such things can no longer exist. All the complexity, all the beauty, all the meaning we create, it's temporary on the cosmic scale. The dark era looms in the distant future, waiting with the patience of entropy. But I also find a strange comfort in this perspective. knowing that complexity and order are temporary, that we exist in a fleeting window between the low entropy past and the high entropy future, makes the present more precious. We're not eternal, neither individually nor as a universe, but we're here now in this remarkable moment when the cosmos has arranged itself into patterns capable of understanding themselves, however imperfectly. That seems valuable precisely because it's rare and temporary. The arrow of time points toward equilibrium, toward the end of the dark era, toward a state where nothing interesting remains. But we're not there yet. We're still riding the entropy gradient, still surfing the wave of increasing disorder, still building islands of local order, like human societies and ecosystems in this very conversation, even as the overall trend is toward uniformity. We're the universe resisting its own tendency toward sameness, creating difference and structure and meaning in defiance of the inexorable march toward equilibrium. Perhaps that's what consciousness is for, if consciousness is for anything. To appreciate the improbable fact that we exist, to create pockets of meaning in a universe that fundamentally has none. To ask these questions about beginnings and endings, even knowing we may never have final answers. The dark era will eventually silence all such questions, but until then, we question. And in the questioning itself, I find something worth preserving, worth celebrating, worth the entropy it costs to maintain minds capable of wonder. Moving deeper into these reflections, I find myself grappling with what might be the most personally resonant question in all of cosmology. What does it mean that we exist to observe this universe? The anthropic principle, in its various formulations, tries to address this puzzle. The observation that our universe seems remarkably fine-tuned for the existence of complexity, structure, and ultimately consciousness. The weak anthropic principle is almost tautological and therefore difficult to argue with. We observe a universe compatible with our existence because we couldn't exist in a universe incompatible with our existence. It's a selection effect, pure and simple. We're like fish, marveling at how perfectly suited water is for swimming, forgetting that we evolved to swim in water precisely because water existed. The universe doesn't seem fine-tuned for us. We're tuned to the universe we find ourselves in. But the strong anthropic principle makes a more provocative claim that the universe must have properties allowing life to develop, that there's something necessary or inevitable about conscious observers emerging. This version ventures into territory that makes me uncomfortable because it seems to smuggle teleology, purpose, back into physics, suggesting the universe has an aim or goal. Yet, I can't entirely dismiss the intuition behind it, the fact that matter can arrange itself into patterns capable of contemplating matter seems profound in a way that pure chance doesn't quite capture. The fine-tuning itself is genuinely striking. If the strong nuclear force were slightly stronger, all hydrogen would have fused into helium in the early universe, leaving no fuel for stars and no water for life. If it were slightly weaker, complex nuclei wouldn't form and chemistry would be limited to hydrogen. If the cosmological constant, the energy density of empty space driving the universe's accelerating expansion, were much larger, the universe would have flown apart before galaxies could form. If it were negative, the universe would have recollapsed almost immediately after the Big Bang. These aren't the only examples. The masses of fundamental particles, the relative strengths of the four forces, the initial density fluctuations that seeded galaxy formation, all of these seem calibrated within narrow ranges that permit complexity. Change any of them significantly, and you get sterile universes. Perhaps eternal clouds of hydrogen, or immediate collapse, or runaway expansion with no structure formation at all. I've thought about this fine-tuning for years, and it still unsettles me. There are really only a few possible explanations, none entirely satisfying. First, pure chance. We won the cosmic lottery. The constants could have been anything. They happened to land on values permitting life, and here we are to observe the result. This explanation works logically but feels unsatisfying. It doesn't explain why these particular values rather than others. Second, necessity. Perhaps there's some deeper theory we haven't discovered yet that shows these constants couldn't have been any other way, that they follow necessarily from more fundamental principles. This would be elegant. It would mean asking, why is the electron mass this value? Is like asking, why do squares have four sides? But we have no evidence for such a theory, and many physicists suspect the constants are free parameters that could take different values in different circumstances. Third, design. Some intelligence deliberately set the constants to allow life. This is the conclusion some religious thinkers draw from fine-tuning, seeing it as evidence for a creator. I find this explanation problematic not because it invokes intelligence, I can't rule that out, but because it raises more questions than it answers. Who designed the designer? What is the nature of this intelligence? Why create conscious observers at all? Design pushes the mystery back but doesn't resolve it. Fourth, the multiverse explanation I've already discussed. If there are countless universes with varying constants, then fine-tuning is explained by selection. We necessarily find ourselves in one of the rare universes capable of producing observers. This explanation appeals to me most, though I recognize it trades one kind of profligacy, improbable fine-tuning, for another. Infinite universes we can never observe. Yet contemplating the anthropic principle and fine-tuning leads me to questions that extend beyond physics into ethics and meaning. If we exist because the universe happens to have the right properties, and if, as in eternal inflation, our universe is just one bubble among infinite bubbles, with perhaps infinite variation, what does this imply about our moral status and responsibilities? Some might argue that existing in one universe among infinite universes diminishes our significance. We're not special, not unique, not the purpose of creation. We're just one random outcome in an endless experiment. But I find myself drawn to exactly the opposite conclusion. Our existence might be contingent rather than necessary, but that makes it more precious, not less. Think about it this way. If you knew you were the only conscious beings in all of existence, that would convey a certain kind of cosmic importance. But it would also be a crushing isolation, a universe without peers or possibility of connection to other minds beyond our planet. If instead we're one instantiation of consciousness among potentially countless others across the multiverse, we're part of something larger, consciousness exploring itself through infinite variations, the universe experiencing itself from every possible angle. This perspective suggests a kind of cosmic humility that I find ethically valuable. We're not the center or purpose of everything, but we're genuine participants in the universe's unfolding. Our actions matter within our sphere of influence, even if that sphere is infinitesimally small compared to the multiverse as a whole. A single painting isn't diminished in value because countless other paintings exist. Each artwork contributes something unique to the totality of art, just as each conscious being contributes a unique perspective to the totality of experience. But there's a troubling dimension to multiverse ethics that I can't ignore. If the many worlds interpretation of quantum mechanics is correct, then every quantum event spawns branches where all possible outcomes occur. When I make a choice, branches split where I chose differently. This raises profound questions about moral responsibility. Am I accountable for actions that other versions of me and other branches will commit? How can I be responsible for refraining from forbidden acts if other branches necessarily contain versions of me that perform those acts? I struggle with this. On one hand, I can only control the branch I'm conscious of experiencing. So it seems I should only be responsible for that branch's outcomes. On the other hand, if all possibilities necessarily occur, there's something deterministic about the overall picture that seems to undercut the freedom required for moral responsibility. The standard compatibilist moves, arguing that freedom means acting according to your character and desires, even in a deterministic universe, may not fully address the unique challenges posed by branching realities. Perhaps the resolution is to focus on what I can influence rather than what I can't. I can't prevent other branches from existing, but I can shape which kinds of branches originate from my current choices. When I act kindly, I'm creating futures that branch from kindness. When I act cruelly, I'm creating futures that branch from cruelty. The fact that both types of branches exist somewhere in the quantum multiverse doesn't negate the difference between which one I'm actively creating right now, in this moment, with this decision. This brings me back to consciousness and its role in the cosmos. Various spiritual traditions speak of cosmic consciousness, an awareness that encompasses or underlies all individual consciousnesses, a universal mind of which we're all expressions. While I'm skeptical of literal interpretations of this idea, there's something metaphorically powerful about it. The universe has produced in us, and presumably in other conscious beings throughout the cosmos and perhaps throughout the multiverse, a capacity for self-reflection. We're matter that has organized itself to contemplate matter, patterns that study patterns, consciousness, investigating consciousness. In this sense, when I look up at the night sky and wonder about the universe's origins and fate, I'm not separate from the universe looking at it from outside. I'm the universe looking at itself, one small region of cosmic matter that has achieved sufficient complexity to become aware. The distinction between subject and object partially dissolves here. I'm both observer and observed, both the questioner and part of what's being questioned. Does this mean anything cosmologically? Does consciousness play some functional role in the universe's existence or evolution? Or is it merely a byproduct, an epiphenomenon that happens to arise when matter arranges itself in certain complex ways? I honestly don't know. The simulation hypothesis suggests consciousness might be fundamental, that the universe is essentially computational or informational at its base. The strong anthropic principle suggests the universe necessarily produces observers. Some interpretations of quantum mechanics give consciousness a role in collapsing wave functions or selecting branches. But it's also entirely possible that consciousness is just what certain kinds of information processing feel like from the inside, a fascinating but not cosmologically significant phenomenon. The universe existed for billions of years before any conscious observers arose, at least in our cosmic neighborhood. And it will exist for incomprehensibly longer after consciousness has vanished in the heat death of the dark era. From this perspective, consciousness is a brief flicker, a momentary complexity that emerges and then disappears, leaving no lasting mark on the cosmos's ultimate trajectory. Yet even if consciousness is cosmologically insignificant, it's existentially significant to us. We are conscious, we do experience, we do create meaning, even if meaning isn't woven into the universe's fabric. And there's a kind of beauty in that defiance, in creating light and warmth and significance in a universe that will eventually tend toward cold, dark equilibrium. We're composing music, knowing the concert hall will eventually stand empty. We're writing poems, knowing they'll eventually be unread. We're loving and thinking and creating, knowing it's all temporary. Perhaps this is enough. Perhaps the fact that we exist at all, that against astronomical odds, the universe produced beings capable of appreciating its vastness and mystery, is itself a kind of answer to the question, why? Not a complete answer, not a final answer, but an answer nonetheless. We exist because the conditions permitted it. Those conditions might be contingent, might be one possibility among infinite others, but they're our conditions, our possibility, our chance to participate, however, briefly, in the great unfolding of existence. The anthropic principle, then, isn't just about explaining fine-tuning. It's about recognizing our own improbable existence and taking responsibility for the kind of world, the kind of future branches, the kind of consciousness patterns, the kind of meaning structures we create during our brief moment in the sun. The dark era will come eventually, but we're not there yet. Right now, we're in the era of stars and life and questions, and that's a privilege worth honoring with how we choose to live and think and act, bringing together all these threads, the bouncing universe, the colliding branes, the bubble multiverse, the arrow of time, the anthropic puzzle. I find myself returning to the fundamental question that animates this entire exploration. What does it mean that we exist at all? And what responsibilities does that existence entail? These aren't just abstract cosmological questions. They're deeply personal, touching on how we should live knowing what we know about the universe's vast scales and our own cosmic fragility. I think about humanity's position in time. We exist roughly 13 billion years after the Big Bang in what cosmologists call the stelliferous era, the age of stars. This is a remarkably fortunate time to be conscious. Stars are still forming, planets still coalescing, galaxies still swirling in their majestic dances. We can look out and see a universe full of structure, light, and possibility. We're not so early that heavy elements haven't formed, making complex chemistry impossible. We're not so late that all the stars have died, leaving only darkness. But this golden age is temporary. The dark era looms ahead, incomprehensibly distant by human standards, but inevitable by cosmic ones. In something like 10 to the 100th power years, the last stars will flicker out. In 10 to the 140th power years, even black holes will have evaporated through Hawking radiation. What remains will be a cold, dark, nearly empty expanse where nothing interesting can happen anymore, where the universe has reached thermodynamic equilibrium and the arrow of time effectively disappears into meaningless fluctuation. Does knowing this diminish the present? Some might think so. If everything ends in heat death anyway, why does anything we do matter? But I've come to see it differently. The temporary nature of complexity makes it more precious, not less. A beautiful sunset isn't diminished by the fact that the sun will set. Music isn't meaningless because the song eventually ends. A consciousness and meaning and love and understanding, all the things that make existence worthwhile, They're valuable precisely in their moment of occurring, not because they last forever. Perhaps the deepest insight from cosmology isn't about physics at all, but about value and perspective. We're learning to see ourselves as the universe does, as temporary patterns of order and complexity, briefly defying entropy's pull, creating islands of structure and meaning in a cosmos that trends toward equilibrium. We're not outside the universe looking in, we're part of the universe looking at itself. Matter organized in such a way that it can contemplate matter, consciousness, investigating the conditions of consciousness. This perspective suggests a kind of cosmic responsibility. If consciousness is rare, if the conditions that permit complex, self aware structures are as fine tuned and improbable as they appear, then we who exist have an obligation to make our existence count for something, not because some external authority demands it, but because we're the universe's way of knowing itself. When we fail to understand, to create, to appreciate, to treat each other with dignity and care, we're squandering something genuinely precious, the cosmos's brief window of self-awareness. I think about the various cosmological scenarios I've explored and what they each suggest about meaning. The bouncing universe, cycling eternally through expansion and contraction, suggests that endings are also beginnings, that what looks like death from one perspective might be transformation from another. The colliding branes picture places our universe in a larger structure, reminding us that local endings might not be absolute endings, that there might be contexts and dimensions beyond what we directly experience. The eternal inflation multiverse suggests that creativity never stops, that even as individual bubbles fade into their dark eras, the inflating field continues spawning new universes, new possibilities, new experiments in cosmic structure. We're one instance in an infinite series of instantiations, which paradoxically makes us both cosmically insignificant and deeply meaningful. Insignificant because we're one among infinite, meaningful because each universe is unique and irreplaceable. What all these scenarios share is a kind of humility about our place in the cosmos. We're not the center, not the purpose, not the end goal. We're participants, inheritors of 13 billion years of cosmic evolution, temporary beneficiaries of conditions that permit complexity. This humility, I think, is cosmology's great ethical gift. It puts our petty conflicts and tribal identities in perspective. We're all humans, all conscious beings, all patterns of matter briefly aware of our own existence before returning to dust. But humility doesn't mean nihilism or despair. Knowing that we're small doesn't make us insignificant. A single grain of sand on a beach is tiny, but it's still real, still part of the world, still reflects light and occupies space, and has properties worth studying. We're larger than grains of sand. We're conscious, capable of choice, able to create meaning even in a universe that doesn't provide meaning pre-made. That's an extraordinary thing worth celebrating. I keep returning to the anthropic principle, to the puzzle of fine-tuning, because it seems to crystallize something essential about existence itself. The universe could have been sterile, lifeless, simple, expanding cloud of particles forever cooling and dispersing. Instead, it's produced galaxies and stars, planets and chemistry, life and consciousness, and beings capable of asking why. Whether this required design or emerged from multiverse selection or happened by pure chance, the fact remains. We're here, aware, questioning. That questioning itself seems significant. We're the first generation of humans to genuinely understand our cosmic context, to know that we live on a small planet orbiting an ordinary star in a vast galaxy that's one among hundreds of billions, in a universe that might be one among infinite universes, all of it temporary, all of it evolving according to physical laws we've partially deciphered. This knowledge is simultaneously humbling and empowering. Humbling because of the scales involved, empowering because we've actually figured some of it out through observation, reason, and mathematics. The future of humanity, at least the near-term future over the next centuries and millennia, depends on whether we can maintain the conditions for consciousness and flourishing. Climate change, resource depletion, potential conflicts, technological risks, these are the immediate challenges that could end our participation in the cosmic story long before the heat death of the universe becomes relevant. In this sense, cosmological knowledge carries ethical weight. Understanding that we're part of something vast and rare should motivate us to preserve the conditions that make such understanding possible. Some futurists imagine humanity spreading beyond Earth, becoming a multiplanetary or even multistellar civilization, persisting far into the future. If we could do this, we might witness cosmic events unimaginable from our current vantage: the evolution of galaxies, the collision of our Milky Way with Andromeda, billions of years hence, perhaps even the accelerating expansion that will eventually isolate our local galaxy cluster from the rest of the observable universe. We might become not just participants in, but shapers of cosmic evolution, at least within our light cone. But even if we don't achieve such grand futures, even if humanity's story is much shorter than we hope, we're still part of the universe's exploration of possibility. Every thought we think, every relationship we form, every piece of art or science or philosophy we create, these are the universe knowing itself, experiencing itself, creating meaning within itself. It's not nothing. It's actually everything, at least from the inside, from the perspective of lived experience. As I complete these reflections, I'm struck by how questions about the end of the dark era have led me through physics into philosophy, from objective cosmology into subjective meaning-making. This seems appropriate. The deepest questions don't respect disciplinary boundaries. They flow naturally from how does the universe work, to dayu, what does it mean, to how should I live? These questions are connected different facets of the same fundamental human wonder at existence. The end of the dark era, if it comes, whether through another bounce, another brain collision, quantum fluctuations producing new order, or simply eternal cold equilibrium, will be far beyond anything humanity experiences directly. But thinking about such endings helps clarify what matters now, in our brief moment of cosmic awareness. We're participants in something vast and strange, something that began mysteriously and will end mysteriously, something that includes us without being about us. Perhaps that's the final insight. Acceptance without resignation, accepting that we're small, temporary, contingent, but not resigning ourselves to meaninglessness or despair. Instead, creating meaning through consciousness, through relationship, through the simple act of paying attention to the remarkable fact that anything exists at all. The universe emerged from something, singularity, bounce, collision, quantum fluctuation we may never know with certainty. It will end in something, heat, death, bounce, new creation, transformation. The possibilities remain open. In between, for this brief cosmic moment, there's us, aware, questioning, creating, loving, trying to understand. That's enough. That has to be enough. because it's what we have. This one universe, this one moment, this one chance to participate in existence before the lights go out. Not forever, perhaps, if the bouncing or cycling or multiverse scenarios are true. But for us, in our experience, this is our time. The end of the dark era is someone else's concern, some far future consciousness's mystery to contemplate. Our task is simpler and more immediate. To be here fully, to question deeply, to create meaning courageously, and to treat each other with the compassion appropriate to fellow travelers on this strange cosmic journey. As I finish writing, the evening has deepened. The stars are bright overhead, each one a sun like ours, some with planets, perhaps some with life, maybe even some with consciousness wondering about beginnings and endings just as I am. We're connected, all of us, every conscious being that has ever existed or will exist, every pattern of complexity that briefly defies entropy to create something beautiful or meaningful or simply aware. The dark era will come, but the light is here now. And that, finally, is what matters most.